So let's start from the basics. What is security? When you boil down security, it really comes down to two things: authentication and authorization. Okay, authentication basically is who are you, right? Can we validate who you are? And there's multiple ways of really doing that. We call them entities when you are like kind of a developer, because entities could be kind of anything, right? Like users or even machines and processes that are running on those machines. But they're typically called principles. So a principle could be, again, a user or a machine or a process. And there's many ways of authenticating a principle. Some of the methods are Kerberos, which is kind of more like an older way of doing it, maybe over 20 years old, of verifying or authenticating a user or a principal. There are client certificates, so you can give a certificate to a user or a principal, and you could use that to validate that person's identity. There's an old tried and not so true username and password, same thing as key and secrets. You have a username and a password and you use those credentials. Those are not as secure, but there's other newer, more advanced methods of identifying a principal: OAuth, SSO. I think there are a few others that are not as well known, but yeah, there's a lot of ways to do it. There's also the second half of security is authorization. Who could actually do something? Once I know who you are, what are you allowed to do? If I enter a building with my bags, what rooms am I allowed to go to? Can I go here? Can I go there? Can I even go to that floor, etc.? A lot of that could be when you're thinking of like data. It could be, can I read this data? Can I write to it? Or can I not read it at all or write to it at all? Can I go into this cluster or, yeah, so many things like that. So let me go to the next page. And security, we're going to talk a little bit about security, how it relates to data governance as well. Data governance is just not the regulations, but they are really fundamentally just comes down to these 2 points. There's security, which is authentication and authorization, and then be able to share that data across other users in your business, which is the operability part of data governance. We're going to talk more about the security part of it so that you could use data without breaking regulations, but also share that data so that you could use and get insights and analytics out of that data that you need for your business to feed back to your applications or users, right? The first thing we'll talk about is the cross-border protection. So this is very popular with GDPR and others. With the 3 things I would really recommend here are these really. You need to process your data locally. So if you produce data, say in Europe, you should really process it in Europe. That way, so when you share it outside of Europe, it doesn't have that piece of data that will break GDPR rules, right? So you need to be able to process that data in the place where it originated, and that's really hard to do because normally a lot of data processing doesn't live, and that's the whole purpose of moving that data to another place, is be able to process it in another place, because that's where maybe your data warehouse is, or your data lake, or that's where your cluster that can process massive amounts of data, that's where they live. So you have to share that data outside Europe, be able to get that data and get that insight. So you need to do some pre-processing of the data before you get it to those places, otherwise you're breaking some of the rules, and in particular GDPR. And I talk about a little bit about replicating or sharing. Basically, what that means, you're replicating that data. You're copying it from EMEA or Europe to another place to do that processing, right? And before it reaches that destination, you should really have a way to process that data before you replicate it. And you're replicating it, replicating the protected version of that data only, and leaving what's sensitive in those original locations. And the best way to really do this is to build some kind of lineage. And down here is an example of a lineage graph. This image came from Open Lineage using a tool that implements Open Lineage called Marquez. It's a streaming graph here. You see there are databases that are that look like, the database icon, but they're topics, say in Kafka or Pulsar or Red Panda. And then we do some processing of that stream, and then you put it into another place, and the other place can be outside of the region where data is protected. So these processes here, in particular, are probably protecting the data, either omitting it, encrypting it, or tokenizing, and I'll get into those differences later. So as they get to here, assuming this is somewhere else outside of Europe, we can now process that data and then force that downstream to other users that may want to use that data for analytics. So what are some of these strategies in securing data? There are, ways to obfuscate data. So here's an example of ways to obfuscate data, is to make sure that you're using mutual TLS. So we talked in the beginning the difference between what security is and the difference between authorization and authentication, right? So this is a diagram here with the server and a user, or this could be an application, both with a certificate. These are like encrypted, math-generated code inside some kind of protected file. And these represent each, the server and the client. So this is a client certificate, and this is a certificate to the server. What MTLS is the M being mutual, TLS being the next version of SSL, which is a way to encrypt data on the wire, assuming this arrow here is the wire. What happens with mutual TLS is that the user here is represented by the certificate. So programmatically, we could take the certificate and identify who is sending data across this wire, right? And this certificate here enables the encryption of that data as it passes through the wire, right? So at the end, when this connection is established, they can pass data between each other without having it be in plain text. And these certificates really gives them the authorization. So from the server side, this certificate is using this certificate as a way to authorize or the use of that data, meaning to decrypt it, right? So am I allowed to read this? Yes, so let me run the algorithm that will decrypt it, and so that you could read it. And also works with the authentication part of it. It just tells me who I am. This is my badge as I enter a building. It tells me who I am, and then from the rules that are back in here, it tells me what I can read and write to and from across this wire. A lot of times, there is a version of TLS that doesn't have the M in it, which is just called plain TLS, right? And it still works, right? The only issue is that, not an issue, but the difference is that this person or this entity out here or this principal doesn't have one of these certificates. What does that mean? That means that the server has no idea who this persona is, which means that it is considered anonymous. So there's no way for the client to identify itself. So the server has no way to assign whether this person is who they say they are. And so therefore the server can't apply read or write authorization rules to this user. So as this person, it's like coming into the lobby of a hotel or a building. You know, you don't necessarily need credentials to come into the lobby, but you could walk around in there and but not get into the places where that you would probably want to go. Okay. So there's also encryption of the data. We just talked about a little bit with TLS, but there's also tokenization, right? So again, encryption is a mathematical algorithm that could be derived, that could be derived or decrypted by a recipient. What that means is that when we run a mathematical algorithm against some plain text data to encrypt it so that nobody can read it, like a bad actor, it can be derived or decrypted by the end user because they know each other and have those mutual certificates. They have the information they need to be able to use or derive that mathematical algorithm to get the original value of the message. In this case, they're passing what looks like to be social security numbers and possibly other things, right? But tokenization is different. This data can't actually be derived. It needs to be looked up, right? So what it is that when you have, say, a social security number in your payload of your data, when you tokenize it, sometimes it'll replace it with some other value. Sometimes that other value may still resemble the original value. So let's say it was a social security number. It may have the dashes in between the first three and the last four numbers, or a phone number. You know, it may look like a credit card number, right? But it can't be derived. So there's no mathematical algorithm that I can use to take that data and derive it. It has to be looked up, and that looking up is done through some token system where I take that token, request that, and that tokenization system tells me, oh, are you who you say you are? Are you allowed to read this? And if so, will provide me the original value that the token replaced. So that's the difference between encryption and tokenization. Tokenization, basically, you can't derive the original value, but requires a separate system to hold the original values in. In encryption, you can derive the original value using a mathematical algorithm. This is not advancing. What's going on there? There we go. There we go. So make sure I went too far. Here we go. Another way of protecting or obfuscating your data is masking. These are methods that will not allow you to retrieve the original value. They're just replacing the original value with something else, right? In Apache Flink, there are functions you could use to just hide that. Here is replacing all the values as the social security number. If you were to give it different patterns or different numbers, this is what happens to the data as it starts to get masked. So if you want to keep some of the data, not all of it, you could do that by using this overlay. There's also regex replace. That's also a function inside Flink, well, and many other systems. Here's a social security number. This is a regex here that says replace everything that is a digit with an asterisk, and this is what it returns. So this is another way to mask your data, but you can't get the original value of it. This is probably something you would do, say, for GDPR if you didn't have it, but don't want to necessarily replace it or encrypt it. You can just either omit it or mask it here. Other ways of protecting your data, there's things called role-based access control or RBAC, and then attribute-based access control. Role-based access or RBAC is more popular. Basically, you give yourself a role, or a user or a principal is assigned a role, and under that role, you are allowed to do certain things, like you could read or write from a table or a file or a directory or a topic in Kafka, and so on. Attribute-based control is a bit more complex. And you could read a little bit about it here, but I'm going to show you in the other slides a visualization that better describes it. So this is, again, role-based access control. These are roles: chief, head, and maybe worker. And you could assign access level controls to each one of them, right? But if we go to the next one, this is attribute-based control. What this is that it's very similar to role-based access control in that you're using the user attributes, the name, and the role and position and clearance level. But not only that, you're taking attributes from other places, like the environment, what time it is, where you are, and the threat level. So in combination with the user attributes in the environment and possibly the resource attributes, the thing that you're trying to read or write to, when it was created, or the resource, the owner of it, many more things you could add to here. You could apply rules that incorporates all of these and decides whether you have rights to read, write, etc. Okay. It's a bit harder to handle, but I've seen customers actually want this in the field that I've worked with. Okay, so the next really important thing I would say is to always be monitoring your data. You need to know what actions are being taken upon it, and to be able to read that in a place so that you can get alerts from. So I should give you an example. This is an example of like a stream inside Decodable, and it called events. It has all the activities. You can see that the connection has been started, it's been activated, a pipeline or a SQL has been transitioned to running. A lot of other systems have this similar audit log where you could see them provide permissions to give access to somebody, or somebody's accessed a piece of sensitive data, right? Even though they have permissions, that's still logged inside an audit log. You can send all those logs to a system like a SIM system, which is a way to monitor sensitive events in your business, and decide apply alerts on things that you think may be worth investigating, right? So I think it's always important to be able to monitor some of these things or all of these things in a way that that you could feel that yourself can feel secured, as well as your customers.
Hey, Hubert, this might be a good place to pause for just a second and see if anybody had any questions. So I want to give everybody a window to do that. So are there any questions? Okay, well, if you think of any, just let us know. Sorry to interrupt you, Hubert.
Hey, no problem. This is good stuff. This is what basically a SIM is. This is security information event monitoring. A lot of tools out there like Splunk, QRadar for IBM are examples of these things. They all send data into it to a SIM so that you could monitor and alert from it. Getting some issues with, there we go. Make sure I didn't skip any pages. Okay, so security when working with a SaaS product. So this is where a lot of vendors or customers really prevent themselves from taking advantage of the cloud because of concerns of security when working with a SaaS vendor or fully SaaS product. What you could do is to really ensure that when you speak to these vendors that they have a way to erase the data, right? One is retention. You know, how long do you usually hold that data? Do you need to be holding data for a certain amount of time? A lot of systems out there, like Kafka, for instance, have a default retention. It will start to purge old data. But there's other things that are a bit harder to erase. For instance, like your data in your data lake or data warehouse. A lot of times you need to copy, rebuild these systems to erase the particular records that have requested to be deleted, right? So you have to rebuild some of these things, especially if they're immutable stores. You just have to rebuild the system, the table, for instance, and then have the clients that were reading from them point to the new version of that table. There's also change data capture, right? You have to make sure that if you are replicating data, or that you're replicating it to a destination that is, also protected. So if you protect it from, let's say, for instance, if in one database you have a bunch of users with their social security numbers, and then when you delete somebody from that table, what CDC does is that it'll send a delete record out of that database and send it into, say, a messaging system, for instance, decodable. What will happen is that delete transaction will get to the destination database and execute that deletion itself, so that there's a mirrored view, or the data is completely mirrored from the source and destination. So by using CDC, when you delete something from the source database, you're almost guaranteed that record will be gone in the destination table, because you are using these change data capture records flowing through your streaming system. So that's a technique that you could use to ensure that your deletions get propagated throughout the system into your enterprise. Also, there's private networking in the cloud, depending on whether you're in AWS, which is over here, or actually down here. Azure, which is called VNet, and GCP, which is also the same. It's also called VPC. What private networking does is that the main issue with the SaaS vendors is that they have public endpoints, meaning that they have ways to get into their system publicly, right? So by creating private networks, a lot of these endpoints, public endpoints, get removed, and the only clients or endpoint that are allowed to speak to are the peered VPC. So this could be a customer yourself, and over here a SaaS vendor, and there's a private connection. Well, this one will have no internet endpoints, while this one's also no internet endpoints, but within your business's infrastructure. So you continue to use the SaaS services over this protected network connection. In GCP, they have VPC peering is called. In Azure, it's called VNet peering, because their VPCs are called VNets out there. And in AWS, there's private link. There's also VPC peering, transit gateway, and I think so there's some others. I can't remember what they're called, but yeah. So there are a few ways to really protect yourselves, so that it feels like nobody else is using those instances except for your business. So so in that sense, there might be assurance that your data is protected. Right. Every time I talk too long on the slide doesn't want to switch. There we go. Okay. Another way to kind of protect yourself is to manage your own keys. In this case, this is a KMS or key management system provided by a cloud vendor. Each cloud vendor has their own ways of managing keys, and these are the keys that allow you to decrypt and encrypt data, as we spoke about in the MTLS conversation. So this key can be managed by yourself. So you could say, hey, I have my own key. I want you, the vendor, the SaaS vendor, to use this key to encrypt data, my data that you're holding in your systems. What that enables them customers to do is that the vendor can't look at the data because the key is owned by the by the customer. Right. It's not changing again. Let's give it a second here. All right. And the last thing I want to talk about is really bringing your own cloud. What that is that if you go back to this picture over here, there's a VPC here. This is your own cloud. That's what we mean by bringing your own cloud, and that the application or the service itself is split up into two planes: the control plane and a data plane. So the data plane will live entirely in your VPC. They're the customer's VPC, meaning there won't be any data in the vendor or the SaaS VPC. Okay. So that's what the difference there is, that the data lives only in the customer's VPC. The control plane, on the other hand, is still in the vendor's VPC. What that allows this partnership to do is that the vendor can utilize the control plane to fully manage the data plane in the customer's VPC. So that's what bring your own cloud is. The data plane, again, is not in the vendor's infrastructure. Your customer's data is only ever in the customer's infrastructure. Only the control plane lives in the vendor's or the SaaS vendor's infrastructure. And then you can communicate with the control plane. So if this is you as an administrator on the command line, I can invoke some tools and API calls. That tool will call the APIs in the control plane and subsequently call some data plane functions to manipulate whatever's happening in the data plane. Let's say, for instance, delete a record or stop a process, or protect a set or a table or directory or topic or so on. Okay. So that's it. I hope you enjoyed this session. There are many ways there's a lot to security. And this is just really an intro to get started with your data, your moving data, as well as SaaS security. If you have any other questions, definitely join our Slack channel. We're happy to answer any questions on security, especially on streaming use cases, as well as love to know what you guys are doing with your data.